of you have heard of JFrog. Some of you have not. So let's get started with just to understand what JFrog is in a nutshell and what it does. And who knows, and definitely they can resonate with the numbers and the things that we will talk about. So JFrog is actually there in multiple articles at the moment. It's widely recognized in global media as a market leader in the DevOps and DevSecOps domain. We have grown both organically by developing innovative products that add value to organizations, and also through strategic acquisitions of cutting edge technologies and startups to help us get ahead of the market in DevOps security. And specifically now we have also onboarded into ML ops as well. So we have been doing a lot of acquisitions. Some of the names that you might have been seeing like Quark, which is the recent news. And yes, let's take a look at JFrog in a nutshell. So basically, JFrog is founded in 2008, and we've been sticking around from there and sticking around very emphatically. Around 1,500 plus employees spread across US, EMEA, and Asia region. And then we are serving more than 8,000 plus customers, including most of the biggest organization in the world. And we will see some of them, some of the good logos as well. And we are a public traded company on Nasdaq for more than 5 years now. And you see a lot of credentials at the bottom. And these credentials actually represent how JFrog is powering all the major software industry companies. So moving on, I mean, when you see the logos, this list is huge, but some of the top Fortune 100 companies, and many of them are listed. So just to name few, Walmart, Amazon. And if you look at the sectors, all of the major sectors that you look at here, say healthcare, retail, finance, technology, transport, and actually many more. But if you look at the top sectors like this, majority of the majority of the companies are actually, using JFrog as a product. ADIA is one of the the client in the Middle East region. They are also one of the clients. So basically, JFrog helps establishing and accelerating the software supply chain journey. So let's move forward and try to understand the software supply chain ecosystem in general. So we will have a better picture to understand what are the capabilities, and what kind of problem statements that you see in the business, and what kind of capabilities that the platform can offer. So moving on, let's try to understand, what is software supply chain in general. And if you look at the, overall diagram at the moment, you see it in the three section. You see it has been distributed across a curation, creation, and the consumption. So we'll talk about all of them, in detail. But in general, if we try to just understand your software, basically, earlier it used to be, when I say earlier, it's pretty earlier. It used to be like you're always writing a custom code, and the shared code or the libraries or the dependencies were very few. What it means that when you write your custom code, you can ship it to production without any dependencies and any issues at all. But nowadays the things are quite different, because we rely on a lot of open source things, and mostly we want to use things, reuse things, rather than writing things from scratch. So that brings us to a whole new world where you're writing custom code on top of a lot of open source softwares, components, and libraries in general when we say. And here in the diagram, you're seeing them as dependencies. So you do have a source of yours, which is basically the problem that you're solving through your software. And then you have dependencies, and putting them together, you're calling it out as a software. So now, since you understand the major component of your software is actually coming from somewhere else and written by and managed by somewhere else, you need to have a curated environment. You need to have a curated system where you can not only safeguard your source, which usually we do through a source control system like any Git or SVN and many other technologies that helps you there. But you also need to now safeguard your dependencies, because you are dependent on them. So you need to have, a complete ecosystem built, a part of an ecosystem which is built in for you to help you to, create, curate all of your dependencies. And the curate, when I say that, basically you need to have a safe code, you need to have safe dependencies in your system. So there can be many levels of curation, but in general, if we try to understand that if I'm a company running a software in production and I'm dependent on multiple libraries, I should be safe in terms of I should not have any malicious or unwanted, package coming up into my system. So curation is all about, making sure that what you have is basically safe, secured, and most importantly, trusted in terms of, whether you need it in the first place or not. So you can have a good curation, gatekeep in front of you. So assume you have this in place, then you have your source code and dependencies. Now you need to build them. So you come to creation phase where you build them. And when we say build them, it's an oversimplified statement, but essentially you do a lot of activities here, many of them manual, many of them automated, and eventually you build your source with dependencies for a specific target, and that target can be of anything. That basically is the consumption phase. So while we are building your application, there has to be a lot of resiliency in the system, that you exactly should be knowing that, okay, these are the dependencies that is needed for your source, and by the time of your building, the source should be, your dependencies should still be available in the system. They should be temper free, they should be available, and they should be you should be able to fetch them from any globally anywhere in the system, and things like that. But once you build them, now you have your software ready, and that is like ready to be shipped. And when we say ready to be shipped, now you come to the consumption phase and you release it. Now when you release it, you expect it to be deployed to some environment, and that environment can be, if it is typical web applications, then either your cloud-based system, or you are a self-hosted system where you are deploying things on your own infrastructure, or maybe you can build a software which can go to a remote device, where IoT come into picture, and you basically are doing an upgrade of a software to one of the remote handle device, on maybe on a factory, or maybe a handle device on on a consumer end sitting at home. So now you come through the release phase, and then once you release all of these, and when customers start using them, then basically you straight away are using those dependencies in production. And now the phase comes when you actually try to monitor these things. You remediate when you look at some of the issues on production, or basically when you see some of the feedbacks from your usage of your product, and then at the end you start retiring some of the things which are old or you don't need them. So there are a lot of steps actually also involved even after reaching to production. So when we talk about all of this, the most important thing that we miss out, that okay, there's a lot of work here, and DevOps now come into play, where that simplifies a lot of things for you. So DevOps plays a significant role here, with mostly from automation perspective, your feedback loop, and the speed of delivery, because this is definitely not possible at a scale, doing things manually. So DevOps definitely helps us there. So while all sounds very good, until we hear a word called vulnerability in any part of the software supply chain, and there a lot of things that come into play, saying that the DevOps is not enough. You need to have security at your play along with DevOps. So a new term that you hear a lot nowadays is DevSecOps, which is basically an extension, but two great worlds coming together, two different pieces of world coming together, and still solving a big software supply chain problem. So now, once we have spoken about, the beast itself, and understood that the binaries are everywhere in this flow, let's try to understand, what abilities you must expect from a DevOps platform in order to build a great, software supply chain strategy. So to start with, I personally feel these are like the pillars of your software supply chain platform, how you should envision that can solve most of your problems with resiliency. And these are some of the key pillars you need to have at hold of. So as you're working in 2024, you're looking at the softwares which are like extremely resilient, and this is like very complicated softwares. And when we say complicated, it's not about the features that you're building. It's more about that how did you actually build those softwares. And that is nothing but a lot of technologies are there in the play, and many of them are open source, and you combine most of them together and try to build a software which is like the global output of your work. But underneath you have a lot of technologies that are open sourcely available, and basically you use them. So you need to have a system which understands all of these latest and greatest from here to pretty old technologies as well, which are running in the system very greatly. And those are the technologies that you often use it, and you trust them from many several decades, and you still want to run them on production. So there is a wide range of technologies in the system, and you want your platform to have those support, that it can support any kind of technology that you bring in. So binary coming from say Python, Java, and many other subsidiary field when you want to host them on, say cloud. Say Kubernetes becomes one of the most common platform nowadays on cloud. So many other packages like Helm are, it's endless. The list is endless. So you need a platform which can actually understand all of these technologies, and you can host those binaries for yourself, and it can make you enable, bring all of those binaries in your system as you wish and when you wish. Moving on, basically, when you have all of these technologies supported in your system, you need to optimize a lot of things, because we are talking about a lot of binaries. Even if your software is small, you might be using a lot of third-party binaries. So the numbers can grow gradually to drastically as well, depending on what services or what product that you're offering. So you need to have a platform which can capture the metadata, and a metadata in the sense that you can actually have a controlled policy driven system in place where you can use those metadata in terms of controlling the flow of the data, or maybe security of the data, saying that okay, and most importantly, the access of the data. If you're producing something which is very sensitive and you don't want them to be broadly be available across any level of your company, and you want some specialized people should have access to, you need to have the metadata in place so that you can tune them and tie them with some policies, so that at least you have the role, you have access based system in first place. And having said that, when you move on and you have a system in place, you expect that the platform to be unified. What it means that you don't have a single duty that you're performing from a platform. You have tons of other duties. Most importantly, say you are holding artifacts. When I say binaries, which are eventually the term can also be used for them as artifacts, and you hold artifacts. When you're holding artifacts, that means you need storage for them. So you need a secure storage for your artifacts. You need security around them, that from every the moment your artifact comes into system, from there it reaches to production after bundling it to some other software. At the end, you need to have a secure platform. At the end, you need to have automation in place, which means that any part that we're talking about, most of them you'll automate in a real DevOps experience. And you want to have very minimal work, so that of course it's an error free thing, and it doesn't bring fatigue to your process. And at the end, distribution, where you if you're locally distributed, which means that you have one data center, or you have one production house, and you just every time you roll out there, that's fairly fine. But what if you have customers sitting across the globe, and you need to now distribute your final binaries that you produce? You need distribution capabilities built in from the platform. So you need to have a holistic unified platform. And while we are talking all of this, it needs to be centralized as well. Having said that, you can't have multiple pieces of components, distributed across multiple products. So suppose you have a binary, and you're going through a binary being hosted in some place, but other benefits of the platform are coming from some other services which are not part of your platform at all. While this is not a problem, this can become a little extra maintenance on your end. This can become a little complicated. It can bring some more complications at production for you to manage those systems separately. So how about you need to have a platform, a unified platform, which is all delivering at centralized binary repository. That means you can look up into the binary at one place, and you can organize them, and you can distribute them wherever you need them. And in general, you can say you can replicate them wherever you want them, in production. And then at the end, what you expect at the end, saying that you need to have a seamless release to everyone, because you have managed your binaries, you have hosted them, you have built them through automation, and you have secured them, and you made sure that your software is actually production grade. Now you need to release them. So your platform should have the ability to even connect to your final destinations of your binary, be it a device or servers, be it a typical architecture or a complicated architecture. It doesn't matter, but you need to have all the entry gates that somebody can connect to your system as an output, and basically you can push your updates to that particular system. So now, releases or upgrades are, very important, especially when you have, multiple production site. So I would personally like to understand, from the viewers who have joined the webinars, that with the help of a small poll, that across, how many countries is your production, currently distributed. So basically, if you're a service company or if you're a product company, you should see a poll now coming up. So if you're a service company or if you're a product-based company, it doesn't matter. At the end, you deliver a software, and you would definitely have gone into some production. Let's take a couple of more seconds to see some results. All right, I think we have a good, and let's take a look. Well, as expected, it usually is more than one side. So yeah, we see, and it's a very usual trend that you have more than one production sites. And now I would like to, share Cisco's journey, of searching for a robust DevOps platform and how they identified JFrog as a platform, best suited for their needs. So let's try to understand, JFrog's story. I mean, basically Cisco's story along with JFrog platform onboarding and why exactly they come, they needed the, of such platform. So in the previous slide, we, understood that, what should a platform should look like, an ideal platform should look like for you if you are, releasing software efficiently. Uh, so Cisco was actually basically is a globally distributed company. It has, thousands of engineers working for, multiple products across the, the system, and, managing a product, built with multiple, technologies. So what we're talking about is like a scaled, customer environment where they're solving a problem or multiple problems for the customers, but, at the scale of development that they have is huge. So what they needed a basically a robust and, highly scalable system. But underneath, you know, you out of the box, you want a lot of benefits to be enabled so that, most importantly, you should be able to host your binaries efficiently. You should be able to access them on demand very efficiently because you're globally distributed. So of course you have some targets in sense that if you look at some numbers here that they achieved 10 million daily downloads, which means you can imagine that how many engineers were using the binaries on a daily basis. And this is some targets that they've gained after going to JFrog platform as a partner. But we would like to understand that what exactly is few of the the key things that they found with along with JFrog platform, which helped them to choose the platform in the first place, after their evaluation. So now, since we have understood the expectation, let's try to understand those few points. So these are the key 3 points we could draw out that where Cisco chose JFrog platform in the first place. So first, as I said before, is of course uh, they are sitting on multiple technologies, and you need a platform which can actually you can trust on, which already supports all of these. And when we say support, not only support in terms of just saying that okay, there is a binary, you can host it of type say npm as a package manager, so you can host npm libraries. But more than that, in sense that you can have some smart capabilities on your end to cache it on a specific data center wherever you need it. So if it's distributed very nearby to you, you should be able to fetch things faster. And when you have a lot of technologies built with a lot of features on top of it, one of or two of the features actually helps you immediately to boost your current problem system. And one of them was replication. So Artifactory, which is the primary binary manager of JFrog platform, and it's one of the biggest in the world as well. We have that a concept of repositories where you store the binaries or say packages in simple terms. So let's say you have a package of type npm, so you're building a node application, and you want all of these repositories holding all of these binaries to be available across multiple geolocations where your developers are sitting. So since you're globally distributed, you can host it in one place. Say, if they're sitting on US in one particular region, you can host a data center in your data center, you can host one instance of JFrog Artifactory, and it should be good enough for you to serve. But there are other capabilities on the network that limits you. So what if somebody across the globe tries to, access the same binary? Of course they will be able to fetch it because it's a network, so at the end you will get it. But of course network has its own limitations, it's had bandwidths. So how about, I can host another Artifactory instance closer to, the other developer region, which is maybe sitting in India, and they are two worlds apart in terms of, geolocations. So you need another Artifactory instance, absolutely fine. But how about the binary sitting in US? How I can automatically bring them into the system? I should not be doing anything out of the box in terms of, you know writing our own script and things like that. So Artifactory has a built-in feature, and that is basically, the artifact replication. We will talk about replication in extremely general terms, that, how you can get benefited. But if essentially what we're talking about is that you have binaries, you have two or more than two geolocations. Basically, there is no limit to it. But if you have multiple geolocations, where people are working or developers are working, you can, replicate them almost in the real time. And there are other methods also how you can replicate. So this helped them enable all of their developers, to access the same set of binaries that other teams were building, and other teams were consumer, and they were, actually accessing them almost at the real time, or almost at on demand whenever they needed, without any, downtime, or whether they any experience, of lag or something like that. And the last important thing that they found out was, the rich, REST API for automation. And this helped them to extend the JFrog platform in the first place. And when we say that, basically there's a lot of API sitting, uh, and they wanted some of the things that, to control from their end as well. So they had their own internal tooling. We had, the JFrog platform has extensive REST APIs, and yes, you can integrate and you can move on. So let's quickly zoom on to one of the problem statement that, one of the capability that solved their one of the biggest problem statement, which was replication. So in typical workflow, if you want to see, basically we are talking about you're distributed across, globally distributed across multiple sites, and you want to now replicate things in, sitting on your repository, and you want to replicate your packages or binaries. So there are a bunch of options available in Artifactory, which is like out of the box. They are just bunch of configuration. They are like, either you can do a push-based replication, you can do a pull-based replication on demand when you need it, and you can either schedule them, or you can do it through the event basis, which means based on some event in the system, you can trigger a replication. And these are like a standard replication procedure, where we are talking about that you can replicate, in a unidirectional way, that, your primary data center is, say, suppose Amsterdam in this picture, and you wanted things to be in Bangkok. Then all we are talking about that, yes, you can replicate from, Amsterdam to Bangkok. But Artifactory also has some advanced replication, abilities as well, like federated repos, where you get all of these smart things, bidirectionally available. uh, like a very standard use case will be, what if the Amsterdam is not the primary site? What if the Amsterdam and Bangkok both are primary sites, and there are active developers building, a lot of tools, internal tools, that can be used by other sites of developers. Now both are equally important. So you can have something like, federated repos, where you can push a binary, and they can almost be in the real time basis, will be replicated across the other site. And again, these are like some of the advanced things that you can do, right? So we have seen how, working the binary at a scale, is a classic DevOps requirement. But now that, brings us to a challenge to secure them, because now you have multiple replicas of them. It's flowing through the network here and there, because it's making your life easier. So I would like to, know, how would you perceive a software supply chain attack? So we will launch a poll again, and I'll try to personally understand. It's an open field. So can you quote a software supply chain attack incident, that recently you would have heard of, or maybe something that, comes up in your mind? So we'll take a, so your poll should be up now, and it's a field of, about 200 characters. So you can feel free to write whatever comes. So you have more than one, incident in your mind, you can feel free to log in there as well. So we'll take a couple of, seconds. We'll wait for, attendees to, flush in the answers. And usually these answers actually match. So let's see, I mean, out of this poll, what comes out. I'm pretty excited. Okay, so I think we have given enough time. I think keep on feeding the answers. Okay, so I think the very typical answer that we get, and yeah, rightly answered by few of the poll, few of the viewers, Log4j attack, one of the most common one that we have heard in recent years, and it's also called, say, Log4 shell. We also call it with that name, and it's a very common thing, but we are talking about it very commonly now sitting in 2024, but it was extremely chaotic vulnerability back in time when it was like actually discovered. And the biggest problem with this vulnerability, it was a 0-day vulnerability, which means you know it has been discovered as of today, and sitting today, nobody has any patches for it ready, nobody knows about it in the first place. So while attackers are actually trying to really use it on every single potential targets that they know of, they want to penetrate systems. At the same time, the the original maintainers of the particular system is actually you know uh, trying to understand what is the probable root cause of such things, and they're looking for a patch. So that's a scary moment. And when we talk about log4j being so popular in space of Java applications, where it is getting used for logging tool, it becomes much more dangerous because your blast radius is extremely high. So it is it is extremely common to talk about it, saying that okay, it attacked. But the sad part of this is you have DevOps in the system, but you still see in picture that even still in 2024, a lot of companies are still running on production with some of the versions of Log4j which are still vulnerable. So some stats about it, right? So about 1 million attacks have been performed globally, within 72 hours of when it was actually discovered. So you can understand that, the world is not silently sitting just for you to wait and launch something on production. People are also waiting to attack you at the same moment. And that's scary. And several other types of, attacks can also be performed. So let's try and, see what are the security risks involved in each, phases of software supply chain. Well, this is a big list. Okay, so we have talked about a lot of phases, and these phases can also be broken down into multiple, smaller sub phases. But in general, see, if you look at these 7, 8 phases that is there on your picture, they're the broader ones, and 61% of the companies are actually impacted in some or other phase of it. And every single phase that you look at it, probably you might be able to gatekeep one or gatekeep two, but not all of them. This is the problem that people actually have when they are they're trying to onboard in one or more platforms. So the goal at the end that you want from a platform is like, when you talk about every single aspect of these attacks, be it, say, at the curation phase that we talked about, like a malicious package can be injected in your system. So that is fairly possible. You don't have a entry gate where a list of malicious packages which have been already published, that the certain version of a package has already have a critical vulnerability sitting. You still let them allow in your system. So you need to have a gatekeep. You need to have a curation system built in on your platform so that actually you can stop them. And every phase actually brings you a different kind of challenge in terms of vulnerability. So it doesn't tell you that okay, if you are early in the phase, it's a lesser known problem, so you are okay, you will figure it out later. But it doesn't mean that when you are actually on production, when you have deployed your system, you can't have issues there. So a classic example is like you can have a binary being tampered while you have deployed, or while you are about to deploy one of the projects, and you build something but you end up deploying something else because the binary has been fully tampered in between. So see, the scale of the problem is completely different. You were in very early stage where you were writing code with bunch of binaries. Now you have a malicious package now silently sitting along with your code and you're building it. While this is scary, you need to upfront scan it, and you should be get rid of them as early as possible. But having said that, you can also reach to production. So you need to have safeguards even on production, and in even every phases of it. So we talked about 0 day as a term in between. So suppose you have reached to a state where you're basically you've curated all of your primary artifacts along with you want to build your package, and now you're on the creation or building up your package phase. Now at that particular time you discover, do you have any 0 days vulnerabilities available as a system, and your platform should have the upfront available the benefits that you can get out of them is that can scan and that can give you the data upfront. Now, most of these phases, extensively rely on, open source software because we'll see some of the stats that why are we saying that most of them depend on open source software nowadays. But let's try to understand what's the market share of, open source software in first place. And while we are talking about open source software, it is having said that it doesn't mean that it cannot be in, proprietary solutions. It can be a completely internal solution, but you may have one single package for sure, in one of your packages, which can lead you a vulnerability from outside world, which is not developed within your system. So if you see some of the numbers, if you look at the diagram, that beautifully depicts, how your code is actually there sitting on production. So you have a open source layer. Below that, if you see, you mostly run your code on production using containers. You host them on operating system, and you have infrastructure at as code sitting up, to bind all of this together, and your software can go on production. And what you're writing is basically here a code which is sitting and solving your business case, and you're not worried about anything else. You're just leveraging someone who have already contributed. And if you look at the number, they are staggering. 99% of the Fortune 500 actually use open source. So which means that, if majority of the companies are using, open source softwares, there are chances are extremely high that even you are using it. And if you look at the modern software, these numbers are even, mapping up. So all the modern softwares are mostly, about 85 to 90% of code or 90% of the libraries have been open source. And there are only few which is built in or sourced inside or developed inside, which you can maybe think of that it's scratchily written and there is no vulnerability sitting on them. And if you look at the CVE rate, that's even staggering because the increase is basically 57%, which is quite a lot. And this is growing year on year. While many of the remediations are coming in the system, but it doesn't mean that it's not growing. That means attackers are finding many other ways to even exploit your system. So this is not like a rule book where you have seen some of the CVEs or some of the issues already reported in production, and them basically, okay, I just need to get rid of them, but there are like more strategies getting developed. So here we will see that basically a couple of examples that it is not about only software that you are writing. It is not about only the library that is solving your business problem. There are so this particular diagram gives you a high level spectrum of there can be other issues on your infrastructure layer as well. There can be very low level attacks on your network. There can be very high level attacks on application layer. But eventually these are the various types of attacks that has been recorded. And you can see the potential loss sitting next to it. So what it means that none of your OS is protected. That means you have to have protection from the very low level of your network to OS to your application layer. And while we are talking about this, whole spectrum, and we are trying to, sensitize, the world that, okay, there are problems sitting in the network. There are problems sitting in every other layer above the network. But the most important thing that you lose out of this is basically the trust. So it doesn't matter at what level you have got a vulnerability. It's scary. It's definitely scary. You're running a system on production, and if anything is vulnerable sitting on your product or your services, basically it's extremely scary. So what you lose the, basically it actually abuses, the trust relationship between the parties, basically your consumers. And the vulnerabilities mostly abuses the trust and relationship between parties. And I think this is the most damaging thing. And next slide, what we will try to understand that since we have understood so far that the various types of attack, the gravity of each attack or each segment of an attack, while they all sound extremely scary, all you need is basically a platform, a unified platform that can help you to go across all of these phases and help you retain the trust. So this is a big blueprint of how JFrog software can actually help you an entire software supply chain journey. So If you look at it, this diagram is also split into three different segments. We have code, we have build and test and deploy. Exactly similar to what we discussed in first slide. How does a typical software supply chain looks like? So when you're sitting at the code and while you're writing your code, the chances are extremely high that you are least bothered about it. But trust me, this is the phase where you should be most bothered about it, because this is the entry gate of a vulnerability coming into your system. If you protect it, probably most of your issues are actually solved, which are of a certain nature. So what are the things that you can look at? So you're writing your code, so you can definitely scan your code. That's one of the possibility. And JFrog platform has tools like X-ray and advanced security systems, JAS. And with them, basically, you can inspect your code and you can look for some potential patterns and several other ways to really find out that your code essentially that you're writing at the moment may become vulnerable when it reaches to production. And by that, when we are saying that, it is all dependent on, we have the history. We know exactly, what kinds of attack have happened. So based on the history, we can protect on the future code as well. Now, since you've protected your code, you have binaries coming in from the outside world. We talked about curation. You can have, systems like, we have systems like Frogbot. With JFrog CLI, you can, or IDE plugins, you can integrate Frogbot-like system, which is backed by, say, X-ray, which is which performs all of the composition analysis and many other factors. And on top of that, you can actually, curate your binaries, and you can protect your newly, freshly written code as well. So when we talk about all of this strategy at the code level, we try to shift left on the things. So this strategy, we call it shift left. And basically we try to bring all of these scannings upfront in your code. Now, after this, when you come to the build and test and release phase, there are X-ray and advanced security also helps you even on the building. I mean, once you build and test, and when you produce your binaries, it can also help you to scan those binaries. So you need an automation platform in between that can, and Artifactory is a platform that is fully integratable. That means even from any CI tools you can integrate, and you integrate and you build your software and you automate that flow. And now you reach to a phase where you try to take your binary and want to deploy them. So JFrog also have a new product offering from the security domain is a runtime security vulnerability scans. What essentially it means that basically it can scan your production systems. Having said that, it's like majority of the launches that we are doing is we usually host it on Kubernetes, because it's a cloud era and we want to do things which is niche, which is easy to manage and things like that. And runtime vulnerability scan can help you really scan your entire payload or entire workload on your Kubernetes, and that can give you a real time, almost real time feedback on what are the threats running and how do you patch them. And an interesting thing is you can figure out the source as well. And now comes to deployment. Your platform eventually, when it is resolving all of your security, parameters, it's all checking up all single parameters out of your binary management system. Eventually, it should have ability to really put you on production. So if it's a handheld device or it's an IoT device, JFrog platform has Connect, which can actually update and control all the IoT device or IoT fleets, and it can actually go and distribute all of those edge devices. Or on the other hand, you have distribution capabilities. If you're talking about all the releases you want to be available on production, whether you want to deploy it or not, or you want to just release them so that an on-prem or a hybrid customer can take them and upgrade their private environments, distribution helps you to even do that. Now, JFrog has taken, basically a leap forward in this journey, and it has collaborated with GitHub for even seamless software supply chain experience. So we'll talk about that a little bit. And if you look at this diagram, basically this can depict you in a very high level. So let's break it down on the, two part. If you look at the center, this is, Artifactory binary management that we have talked so far. And in the left-hand side, you see a lot of offerings from, GitHub. And one of the predominant thing that you have been, most of us use it, and probably you are also using is GitHub, source control, the Git versioning tool. And that's a software that's very commonly used across, software development. And it has other offerings like, say, issues, code spaces, and we predominantly use that. It has two more products saying Copilot. That's a very famous, AI based, system at the moment that helps developers and basically to predict a lot of things. You can do code completions, you can do a lot of analysis on your code, you can understand your code in the first place if you're a newbie, and plenty other of benefits. And eventually there are GitHub Actions, which is the CI/CD engine for GitHub. So if you look at it at the left hand side diagram, this is fully connected now with both secured layer of GitHub and JFrog. And you can flush in all of your binaries now to a binary management source. So which means you've got all the benefits of your source code level management to securing them, and you have loaded them into, you can bring them into Artifactory, binary management. And then after that, we have talked about a lot of software supply chain journey that you need to, once you bring in those binaries, you should be able to distribute them. You should be able to do more scans once the binary is fully built, and then you can put them on production. When you say production, JFrog and GitHub basically together will have again a seamless integration on production with Azure serverless, or it can be other offerings on the cloud as well with Azure. And you can have runtime security also plugged in with Azure, which means now you get benefits of both the worlds. You should be able to manage your source code as you were doing before, but now much more seamless and much more faster way. And GitHub Actions for CI/CD and bringing all of those artifacts into Artifactory with the benefits of all of the security layers from both the worlds, you will get it out of the box. So let's do a quick recap. We talked about in the beginning that what software supply chain is in general, and we talked about a lot of phases around it. Then we talked about a typical case study where JFrog platform was able to, please a customer of a very specific scaling problem with multiple solutions, and at a scale, it was able to help them to really launch them across multiple data centers on their system. Then we talked about when the scale is achieved, there are plenty of problems that comes on, securing a binary. So we talked about different types of binaries, attacks that can happen on your binaries, and how JFrog platform can really help you, and how it has multiple product suites where using them you can even remediate all of this thing, right? So hope you got something good out of this webinar, and now I'll open it for discussion if you have any. Over to you.
All right, all right. Thank you so much for that amazing session, Kunal. Throwing so much light on, threats of supply chain attacks and how we must secure them. So we'll give a couple of minutes to, for people to chime in their questions and queries, and probably read out some of them that are, trending. So we'll give a couple of minutes, okay? All right, so we have a couple of questions that we would like Kunal to address here. The first one comes, so we have talked about vulnerabilities and binaries on production. So does JFrog platform have the ability to trace back to the source?
Yeah, of course. I think that's a very good question. So we talked about it briefly, but definitely it has. So I'll take a couple of maybe one very classic example. If you have a web application that you want to host in, say, an environment of say of type Kubernetes, and you have a package that you deploy through say Helm. That's a very standard example of today's worlds of deployment. So basically, JFrog platform offers you many capabilities in between, but I'll name a few. We have a concept called release bundles, and what essentially all it means that they are the bundles that are supposed to go out and distribute or to be used on production, and they are immutable in nature. So which means they are if they are tamper free and you can't mutate them at all in the system. So that means uh, you since you're not able to mutate them, the chances are very low that your talking about a tampered binary in system. But say you need to trace it even for vulnerability or for maybe an issue in the system and you want to trace things back. Every artifact is basically attached to a lot of metadatas. And one of the very common metadata is basically checksum. And I'm talking about out of too many metadatas, we are talking about just one of them. And with the checksums, you can basically you can come back and see that, okay, whether that binary is still available in your system and whether that has been tampered or not. And most importantly, now you need to trace back, okay, who produced this particular binary for me that reached to production. So good thing is we have concepts of build info, and the Artifactory helps you to even map every single artifact with the help of a build info where you can actually trace things back. So build info is basically a bridge between Artifactory and any CI server that is present, and it's an protocol that can connect with any of the CI system. And that what it means that from a one particular binary you can actually trace back to the origin that which particular pipeline has actually built this, and the it has reached to production. So yes, the answer is yes for that.
All right. So thank you, Kunal, for explaining that in detail. I think we will wait for the attendees to chime in if they have any more questions,
Sure.
and we'll get protocol